Why does the electric vehicle industry stand out? A key factor is the motor. It converts electrical energy into mechanical energy, moving the wheels. There are various types of motors for electric vehicles, including induction motors, permanent magnet motors, and switched reluctance motors. Each type has its pros and cons. Efficiency, cost, weight, size, and performance vary. Among these, the magnet-free electric motor from ZF stands out. According to ZF, this more developed variant of an externally excited synchronous motor, FSM, is an alternative to the so-called permanent magnet synchronous machines, PSM. The latter are currently the most used motors in electric vehicles but are based on magnets that require rare earth elements to produce. With the IDSM, ZF aims to make electric motors extremely sustainable in production and highly powerful and efficient in operation. Let's explore the features of this motor. It represents a significant innovation and may be the most impressive so far. I invite you to learn more about ZF's magnet-free motor. Innovation in electric motors. Global companies are intensely dedicated to developing innovative, magnet-free electric motors due to the rapid growth of the electric vehicle market. ZF Friedrichshafen, as well as its German competitor MAHLE, stand out in this field. They have developed unique approaches, with ZF intelligently integrating an inductive transmitter within the motor, resulting in a compact, magnet-free design. This motor rivals the performance of conventional permanent magnet synchronous motors, favored in the engineering of current electric vehicles. Martin Fischer, from the ZF board, states that their technology replaces magnets while maintaining performance equal to that of synchronous motors, where the electric current generates an effective magnetic field. The main advantage of magnet-free motors is the elimination of rare earth magnets, essential in traditional motors but problematic in terms of environmental and supply chain issues. These magnets, from mining potentially harmful to our environment, pose significant challenges. Traditional magnet-free motors, however, incorporate elements such as rings or sliding brushes to conduct electricity to the coils, which increases size, weight, friction, and potential wear over time. For these reasons, many electric vehicle manufacturers still prefer permanent magnet motors, as they are less complicated and more efficient. However, the continuous development of magnet-free motors, especially innovative ones like ZF's, presents promising alternatives. These new technologies can reduce the environmental impact of electric vehicle production and contribute to a more sustainable future in the industry. Motors like ZF's, which combine efficiency and compact design, are examples of technological evolution toward more conscientious and environmentally responsible engineering. Contactless motors and their challenges. The design of electric motors faces a significant challenge: how to deliver energy to the rotating parts without creating friction, wear, or noise. An effective solution is contactless induction. This technique employs electromagnetic waves to transmit electricity to coils inside the motor without the need for physical contact or mechanical components. This eliminates the limitations of brushes or rings, which take up space and reduce efficiency. ZF, a leader in automotive technology, has created an innovative contactless induction motor. This motor, called the rotor inductively excited synchronous motor, has an inductive transmitter on the rotor shaft. Compared to motors with brushes or rings, its axial length is reduced by approximately 3.5 inches. Thus, it fits where a permanent magnet synchronous motor would, without sacrificing power or torque density. This motor, known as the IDSM, surpasses a permanent magnet synchronous motor, PSM, in certain situations, such as driving at high speed. It operates more efficiently than the PSM, as it has no permanent magnets, avoiding eddy currents and heat loss. The IDSM supports higher temperatures and vibrations than the PSM, making it more durable and reliable. ZF's inductive transmitter is more compact compared to alternatives with two large discs on the shaft. It is important to note that one cannot definitively compare these two prototype systems or validate ZF's claims based only on preliminary illustrations. The IDSM is an innovation that shows how contactless induction can enhance the design and performance of electric motors. ZF believes that this technology will allow for more efficient and compact electric vehicles in the future. But how does contactless induction work? Contactless induction is a way to transfer electrical energy or data without direct contact. It uses electromagnetic waves to generate a magnetic field, inducing current in a nearby device. For example, contactless smart cards have a chip and communicate with a reader using this technology. Simply bringing the card close to the reader's antenna is enough to make a transaction. In contactless electric motors,